So I have 4 Databricks workspaces, plus Kafka streams and Fivetran syncs to manage. Across these, I have 21 different assets with zero unified visibility, difficulty chaining dependencies across these workspaces, and in a few minutes, I'll show you how to bring all of them within one view using Dagster. Let's get into it. Now let's start with the data sources. We have Kafka streaming real-time ERP events, invoices, payments, order updates, and CRM events from customer interactions. We have Fivetran syncing Salesforce and HubSpot data, and we also have legacy SQL Server and Postgres databases that we're federating through Databricks Unity Catalog. All of these feed into 4 separate Databricks workspaces, each owned by a different business domain. Customer Analytics produces enriched profiles and segments. Sales Analytics handles order fulfillment and revenue forecasting. Finance runs invoice reconciliation, payments tracking, and financial statements. Marketing builds attribution models and lifetime value scores. And here's the problem. Each workspace is in its own silo. Finance needs customer segments from Customer Analytics workspace, but has no visibility into whether that upstream data is fresh. Marketing's attribution model depends both on sales data and enriched customer profiles, but there's no dependency graph connecting them. If Kafka goes down, nobody downstream knows that their dashboard's broke. And there's no single pane of glass for this so-called data mesh. And this is what most Databricks deployments look like at scale. So let's build a control plane using Dagster. First thing I'm going to do is clone the project and install the dependencies with UV. And you can follow along, the docs link is in the description. Now let's look at the project structure. In defs file, we have the core assets. That's our Kafka ingestion, Fivetran syncs, and legacy database, and cross-domain analytics. Then we'll have our 4 workspace directories, 1 per business domain, and each workspace is configured entirely in the defs.yaml file. And here's the key abstraction. The DatabricksJobOrchestrator component. Instead of writing separate Python asset functions for every Databricks job, I'll configure each workspace with YAML. And here's the Customer Analytics workspace, for example. As you can see, the component takes in a Databricks job ID, the workspace credentials, and a list of assets that the job produces, including their dependencies for other assets in the graph. And when Dagster materializes this, it calls the job within the Databricks workspace and reports a materialization result for each asset here. And the other 3 workspaces follow the same pattern. Sales Analytics, you have a job with 2 assets. Finance, you have a job with 4 assets. Marketing Attribution, you have a job with 3 assets. So you have 4 YAML files, 4 Databricks jobs, and 11 workspace assets in total. And the core assets handle everything else. Kafka pulls ERP and CRM events and materializes those as raw events. Fivetran syncs are tracked as Salesforce data and HubSpot data. Legacy databases are federated through Unity Catalog, and the transformation and analytics layer produces cross-domain outputs, enriching customer profiles, order fulfillment status, customer 360 view, and marketing attribution. So let's start Dagster locally. And there it is, 21 assets across 7 groups, 4 Databricks workspaces, 2 Kafka topics, 2 Fivetran connectors, and 2 legacy databases, all in one graph. Now, when we look at the lineage, we can see that Kafka ERP events flow into Customer Analytics and Sales Analytics. Legacy customer data feeds into Customer Analytics. Customer segments flow from the Customer Analytics into Finance reporting, and sales and customer data converge into the Customer 360 view. So we have the full dependency chain from the raw Kafka streaming to the cross-domain analytics output, and it's visible for the first time across everything. Now let's look at how the Kafka ingestion works. Rather than pulling Kafka on a fixed schedule from inside the asset function, this project uses a sensor-driven pattern. The raw ERP and raw CRM events have empty bodies, and they exist in the graph so we can define dependencies against them. But the actual data processing is triggered by Kafka sensors. A Kafka resource wraps the Kafka connection, bootstraps servers, consumer group topics, and is injected into the sensors at runtime. The sensor factory creates 1 sensor per Kafka topic, replica 0 for ERP events, replica 1 for CRM events. Each tick, the sensor pulls Kafka for up to 30 seconds, batches up to 50 messages, and yields a run request with a batch serialized into run config. The run key is set to the max offset, so Dagster handles the deduplication, so no duplicate runs if the sensor ticks before the previous run completes, and Kafka offsets are only committed after the run request is yielded. So we have event-driven ingestion, not cron-based polling. The sensor reacts to new messages and only materializes when there's new data. Downstream assets see this materialization and they know the upstream data is fresh. So now we built a foundation of 21 assets, full cross domain lineage, event driven ingestion. Now let's see what we can layer on top. So with freshness policies, right now, if the customer analytics Databricks job runs late, downstream consumers have no idea. But because Dagster knows the full dependency chain, I can add a freshness policy to customer 360 view and say this asset must be refreshed every 4 hours, and Dagster will propagate that expectation upstream through the transformation layer. And asset checks. I can add a quality gate on any asset in the graph, validate that the customer 360 view has a minimum row count, check that the data stream matches expectations, or verify that upstream assets were fresh when the downstream assets consumed them. Again, a few lines and you've got quality grades across your entire data mesh. And we can add alerting as well. Dagster can fire off a Slack notification when the freshness SLA is violated, so the finance team knows immediately if their upstream data from customer analytics workspace is stale before their dashboards break. And with Dagster Plus, you get role-based access control. The customer analytics team sees their two assets and their upstream sources, the finance team sees their four, and the platform team sees the 21 asset graph data mesh. Each team gets the view that they need, and nobody is overwhelmed by assets that aren't theirs. And now we have one unified data mesh with full lineage from Kafka and Fivetran sources through our Databricks workspace domains to cross-domain analytics. And all of this was built incrementally with zero disruption to any of the Databricks workspaces. And this is what a good data control plane looks like. You configure your workspaces, connect your sources, and you can govern across those different domains. So try Dagster free today. Link in the description.